Alright, so we're going to look at another example of a three-phase system here. So we have a balanced three-phase system. We have a line voltage of 300 volts supplying a balanced load of a Y-connected system with 1200 watts of power at a leading power factor of 0.8. Now we're supposed to find the current for each line and then the per phase load impedance. And so what we mean by the per phase load impedance is, remember, we have three boxes here. And each of these boxes is at a different phase for the load. And so we want to know what is ZP, is what the second part is. And then the current here, we're basically looking for this current coming in here. My IAA current. Now, there's a couple things we should think about here. First off, is that the total power is 1200 watts. So each load absorbs 1200 divided by 3, 400 watts. Because when we say that the load here is 1200 watts, we're not talking about one load. When they say load, they're talking about the whole load. And then the per phase load impedance is again finding the ZP, but that means if we're doing 1200 watts total, each phase has 400 watts of power being delivered to it. Now, the power factor here, this sometimes throws people off because we're like, oh, wait a minute, how do we do this power factor? What is this power factor going on here? Well, remember, a power factor, go back and you can remember this cosine of theta v minus theta I, which is the cosine of theta, is equal to my power factor. So remember, if you think about this complex power triangle, S, P, and then Q, this being theta here, we're basically getting that the average power over S is equal to 0.8. Okay? So if we're thinking about here average power computation, remember, going back in here, now these again are an RMS. I should probably put that here. I always forget to write the RMS, but it's important to write the RMS because it's definitely volt RMS here. Again, pretty much in this chapter here, we're going to assume that we're an RMS even if it's not specified. But power was, the average power was equal to like Vm Im cosine of theta v minus theta I. Now, yeah, it was kind of over 2, but that was when I was given RMS values. Okay, well that helps me out quite a bit actually, because I can simply figure out what the current is. It's not asking for the phase, it's just asking for what the current is. So I just need to know what IM is. Okay. So if I think about that, well, what's Vm? Vm is not my line voltage. Vm does not equal 300 volts. Remember, Vm would be this Vp, that peak voltage, which is 300 divided by the square root of 3. So in other words, the equation we get here, it's actually a very simple equation. I like this problem because it's really not as complicated as you think, but because we don't have a circuit drawn and don't have a picture, it looks like this is going to be a really hard problem. So the equation, the average power I'm getting is 400 watts. Vm is 300 over the square root of 3. Im, of course, is what we're looking for. But then I have this cosine of theta v minus theta I. But remember, that's my power factor. And so that would be 0.8. And then we just simply solve this for IM. And when I do that, I get 2.89 amp RMS. So that's the line current. Now, you might say, well, what's the phase? It didn't ask for the phase. It just asked for the line current, like the value of the current here. Now, the per phase load impedance, we're going to basically say, okay, well, what kind of load do I have on there as far as a resistive value? And so that's simply pretty straightforward, because if you think about what the magnitude of ZP is going to be, that's just going to be my VP divided by my current, voltage divided by current. That's going to get me the magnitude of my load impedance. Now again, that's not going to give me the phase, but it's not asking, it's saying the per phase load impedance. So this isn't in complex form. So really this should be 2.8, really should be 2.89 at an angle of, let's just say, theta amp RMS. But the problem really didn't give us enough information to know what that angle was, because it just said that we have a line voltage of 300 volts. It didn't say what the phase angle was. So there's no way, we could assume it's 0, but we can't necessarily make that assumption. So there's no way for us to figure out these angles in this problem. So we're going to, again, just look at the magnitude of ZP. Well, that's just voltage divided by current. And so we'd have 300 divided by the square root of 3 divided by my current, which is 2.89 amps, and you get 60 ohms. Now again, technically what that would be, it would be 60 at an angle of some maybe gamma ohms. But again, we don't have that phase angle. But that's it. That's all this problem is asking for. So it's actually a really short problem. But sometimes people see this and they think this problem is a lot harder than it is, because it's not one that we've looked at and there's no circuit diagram, and then, oh, there's this power factor. But that's when we have to go back to these equations we learned in the power section and look and remember, oh wait, power factor, that's just the cosine of theta v minus theta I. So this video is a little bit shorter, so we're going to end this one here and move on with material in the next video.